Okay, welcome back. I'm Nate Foster from Cornell. It's my pleasure to introduce Gergely Pongracz from Ericsson Research. He's a senior researcher looking at network programmability, and he's going to tell us about what's next for P4, a journey around missing features.
Yeah, hi, welcome everybody. So I'm trying to go through a journey that we experienced while we were trying to implement some of our mobile network functions with P4. So first, short introduction into the use case. For the sake of time, I will be very short on this. You will be able to see the slides afterwards. So basically, in the mobile network, the main components we intended to deploy with P4 are the user plane components marked with red. And in that case, we typically require high packet per second, so high intensity and low latency, and if possible, bounded latency. So when it comes to deployment, we could actually deploy the component to different hardware pieces. And that was one of the main reasons we were using P4. So actually, we try to utilize the portability aspects of P4 to run parts of the pipeline on a Tofino switch, for example, part on SmartNICs, CPUs, and maybe also on GPUs. So we envision to have a rich data center scenario where all of these components are available. But then we actually saw that there are some features that would be pretty handy for us if they were in P4. And the first missing feature was buffering and timers. So our main use case for this was the RLC loop. This is actually a retransmission loop between the base station and the user equipment, where the main goal is to actually make sure that the packets are arriving to the user equipment that are transferred by the base station. And because we have no solution for that in the P4 language, we need basically a hybrid solution where part of the pipeline was running as a normal P4 pipeline, and part of the pipeline was running as external entity to the P4 domain. And we thought that the task of this external module was pretty simple. So receive a packet, set a timer, and when the timer fires, resend the packet, or if acknowledgement arrives, delete the packet and then delete the timer as well. But of course, since we were able to deploy it only on CPUs, the performance was hugely different. So like we achieved roughly 5 million packets per second on a CPU core, while a Tofino switch can go up to like 1,000 times of that. Of course, sorry, I almost forgot. And it's not just this specific use case where it would be useful, but if you would actually deploy some TCP or quick proxies or servers, it would be also important. Second missing feature was some events that are, for example, clock-based, and our main use case was the scheduler. So in our case, it would actually collect a few packets and wait for the right time slot when it could send basically the packets to the right channel, and then it would send the packets with high accuracy. And so for this, we would require some kind of buffering, as was mentioned before, some time synchronization probably, and some event-based machinery like that could actually listen to internal clock and could actually fire the events based on that. And for that, we also think on other possible use cases like traffic shaping or keep alive messages would be possible if you would have this feature. Okay, as third, I would say only partially missing feature was the modularization, which would be very handy because, of course, in a larger system, it's good if different parties or different teams, different people can develop different functionalities. And yeah, because of the control blocks, it was, to some extent, it was possible in P4. But of course, you have to develop a common parser and a common deparser block, and some pipeline to glue together the modules. And they were thinking that actually these steps could be very well automated. So, we might have some solution for that, some automatic solution for that. Okay, and some further, maybe lower priority missing items were that are visible on the screen, that sometimes we could utilize multiple accesses to the same table, counter, or register. For example, in the routing and encapsulation case. We could also utilize the conditional header field writing in the parser. And if we could use better the header stacks to support some multi-level encapsulation like GTP in VXLAN or something like that, it could be also handy. But these are, as I said, these are not very high priority stuff. So thank you, that was all. And we are very much open to discussion over these topics.
Great, thank you. Zoom clap. I'm curious if you have thought about how maybe some design proposals, what kinds of design proposals you might make and how you might move them forward through the open source community.
Yeah, we were discussing that, and actually we were also trying started to survey the possibilities. So p4.org, where you have the different work groups or working groups. So I guess I don't really see a very formal way of doing that, but I think after the presentation we will try to write to the language design group, or there are the groups in the community that most likely are the most suitable for receiving such proposals. Or maybe I'm also had a look at over the Slack channels where there are a lot of proposals, I would say. So that I would very much open to any suggestion from your side.
I think the working groups are always delighted to have good ideas come up from the community. Maybe then ask a sort of related question. What do you see for each of these three main extensions? Do you see some technical barriers or kind of key problem that has to be solved, or is it sort of here's a priority, and if we sort of adopt existing designs, we'll get there? Or are there maybe engineering challenges? I think often having some kind of prototype implementation of a new feature can help accelerate its adoption. What do you see as the barriers?
Yeah, I guess it is a slightly different among the different cases, because I guess the first and the third case would be kind of pretty straightforward to implement from a compiler point of view. Of course, when it comes to hardware design, such as Tofino, for example, there might be barriers. So, for example, in the Tofino, there might be some limitation on how much buffer size you can allocate, because that would, of course, occupying memory that could be probably taking away memory from the other tasks, like table size could be more limited in that case, or something like that. So maybe we should. So maybe that is not as easy as we think on the hardware side when it comes to like a more fixed. On the CPU side, I guess everything is doable. The question is the performance. So what kind of performance penalty we pay for that? And I guess for the timer-based events, so the second one, I think that is a more tricky, because that would actually kind of break this assumption that P4 has at the moment, that everything is packet-based. So everything is a reaction to an incoming packet, it seems. For me, maybe I'm not skilled enough, but it would kind of turn this to an event-based pipeline, which is probably a much bigger change than what is possible, at least in the short term.
Yeah, I just on the last point, I would, I'm sure you know this, but I'll mention it for the video. There's a proposal that was published at, I think, Hotnets a few years ago from from a group from, I think, Xilinx and Stanford, proposing to add events to V4. So maybe these two threads can come together and
yeah, we have seen
a
some nice videos so from Nick
yes.
McCallum, for example, and things like that. So we are positive in this that something like that will happen. Yeah, whether in the short time frame or a bit longer, I don't know, but we would be happy to move that forward.
Great. So I think we should stop here for this short presentation, but if you are interested in these topics, please follow up. And thank you so much for the presentation.
Thank you very much.